Share screen. There we go. Over here. Hey, good morning, everybody. Welcome back from fall break. Hope everybody had a good fall break. Is this everybody's first class back from break?
Yeah.
Yes. Yes. Having to come back to second class. Ooh. So a reminder, you have a project that is due this coming weekend. We've covered all the material that you need for that project. The project is, again, making some sort of cool graphs of your data sets of your choice, and then you'll put them on GitHub, make a web page out of that. And again, the purpose of this web page, the purpose of all of these projects that we're doing in this class is so that you'll have something that you can, it'll be out there on the internet, something that you can actually show to future employers, talk about with them, and have something to sort of brag about. So my recommendation is to just focus on making the presentation reasonably nice, something that you would not be embarrassed to show employers about, or maybe even proud to show future potential employers. So I mentioned, or I was talking before class started, that this past over break, I went to a conference in Korea. The conference, it was called Coling. We were talking about machine translation of different languages. And there's a number of things that I do at these conferences, but one of the things that I always do is I find all the industry people and I ask them about what should undergraduate students do who are graduating on either this year or in a couple of years do in order to get good jobs. And one of the things they always say is that they want to see good projects that students have worked on GitHub, that grades are so variable between different schools. Like an A in an intro programming class at CMC could mean something totally different than an A at a different school or whatever the grade is. And so they don't actually care. They don't actually look at all of the grades. Instead, what they look at is the actual projects that people have done. And so that's one of the reasons why we're putting these projects on GitHub, is so that you'll have things to show these employers. I don't think this will affect most of the students in this class, but we're also talking about hiring trends in these companies. So I was talking specifically to people at Amazon and Google, working on different the translation aspects of their systems, or people working on Amazon Alexa, or whatever Google calls their competitor to Alexa, and talking about their hiring markets. I think in general, the market has been slowing down for hiring of computer science and data science people this year because coming off of COVID, companies were hiring a lot during the remote workplace, tech companies able to expand. And at least the people at Amazon and Google, what they're telling me is that they're not downsizing the companies at all. Their products are still profitable. They're just not hiring at the rate that they were hiring, say, a year or two ago. And so to a lot of graduating students, that feels like it's harder to get a job than it was for people a year or two ago. But these companies are all still hiring, and they feel like there's not enough people to fill the jobs that they want. So still a good market, probably will continue to be a good market for a couple of years. The technical stuff for today, again, we're in the topic 7 folder here, and there's a handout in the back if you don't have a copy. It's this quizpractice.pdf, and then we're going to be going over in class this notes.py file. In class today, what we're going to be talking about is something called Syntactic Sugar, and this is something that is going to be on your upcoming quiz for next week. But it is, let's see. So professors always think that all the material in all of their classes is always super important. And so I think this is super important, but if there's one topic in this class that you have to not, if you have to like punt a topic, this is the one to like not care about and to punt. That there's not going to be any, the material in here is not required for completing any of the coding assignments. It can make your life easier for completing the assignments, but it's not required for any of them. And it's just something that you might see other people using a lot, and so it's good to be familiar with. This material is actually also not in the textbook. The textbook, they mention the stuff that we're talking about, and they say that you don't actually need it to complete anything, so we're not going to talk about it. That's what the textbook says. So our references for this, I have some links at the bottom, yes. So the way that this will come up in this class is it will be on the upcoming quiz, and if you choose to use this material in upcoming programming assignments, it can make your life easier, but you'll never be required to. Any questions about anything in the class, administrative or otherwise, before we get started with technical material today? Yes.
I just wanted to clarify like the lab and the project due date. So the lab is due Thursday, but we can also do collaboration for 2 days, and then.
So the lab nominally due last night, like the end of the weekend, and then if you're collaborating, you'll have a 2-day extension. So that is, yeah, Thursday at midnight. And then the project, you have until this coming Sunday, or again with the collaboration extension until Tuesday. Yes.
So we do have a lab this week, right?
And you will have a lab this week, yes. Good questions. Any other questions? Okay. So syntactic sugar. So at a high level, what syntactic sugar is it's a way of taking common like patterns that people write, and they're so common that we have shorter ways of writing them. And Python is famous for having a lot of syntactic sugar in that it supports. And we've actually already seen some examples of syntactic sugar in this class. There's this, we talked about the difference between a for loop and a while loop, and that every while loop can be written as, or sorry, every for loop could be written as a while loop. But for loops are just easier to work with, and so we prefer using for loops when we can. Today, we're going to talk about a new form of syntactic sugar called a list comprehension. And we're going to see that a list comprehension can let you take a for loop, basically anything in this accumulator pattern, which we've seen a lot of, and take it from, say, like 3 lines of code down to 1 line of code. And for some people, that's like super exciting and can make your code easier. But again, it's like never something that's necessary to do. Some people find these list comprehensions really awkward and harder to understand. And it's totally a matter of personal taste and judgment whether to use it or not. So let's come over to VS Code here, and we'll get started talking about exactly what a list comprehension is. There's on your printout, there's something like 19, I think, different problems. The first ones go over a pattern called the, or use a function called enumerate, which we're going to skip over for now. And we're going to start with problem number 4. Normally, again, when we're going over the quizzes, we've been using Python Tutor. It turns out that Python Tutor is not very helpful for list comprehensions. So I'm going to be doing everything directly in VS Code here. And yeah, so we won't be doing Python Tutor, and I recommend not using Python Tutor while you're studying, but doing things directly in VS Code. So problem 4 is this code down here. And anytime we have a new Python file, before we start editing it or thinking about it at all, a good thing to do, a good habit to be in, is just to run the file, make sure there's no errors. basically whenever I'm coding, if I like just need a break from thinking, my brain is like tired, or I don't know, I'm always running my code. Doesn't matter, like it's never bad to run your code too much. So I'm probably like pressing this triangle button at least once a minute, maybe like 3 or 4 times a minute while I'm coding. And one of the bad habits that students sometimes get into is not running your code often enough, because then you start making changes. And if you make too many changes at once, maybe multiple of those changes have problems with them, and you don't notice that until you run the code. So it's always good to just like run your code as much as you can, especially when you first get a file. Make sure that nothing bad happens when you first run the code. So I've already run the code like 15 times in this class, and that's like how I normally interact with VS Code. I'm always running things. If I ever need a break, just triangle button's a good thing to do, never bad thing to do. So the first thing here we're going to do with problem 4, or so what we've seen so far, is that there's no output from this code at all. And the reason for that is all the Python code that I have is somehow commented out with these quotation marks. And so we're going to just consider these problems one at a time, uncommenting them, talk about what they do, and then commenting them again. So we're going to look at problem 4 right here, and then down here we'll run it up arrow, run it, and here's the output. It happens to say, "Hello, Charlie," and we'll talk about why that's the case now. Any questions about just like the problem setup or anything before we actually get into why the code is doing what it's doing? Okay. So the interesting line here, the thing that we haven't seen before, is on line 20. This is a list comprehension. Anytime you have a list, so something that's like contained in square brackets, and you see this keyword "for" somewhere inside the list, that makes it a list comprehension. And list comprehensions always have this format up here. It's before the for loop, there's some sort of computation that happens, and then the name of a variable in the list. And anytime you see this code, it's 100% equivalent to this code right here. Python internally literally just copies and pastes this code down onto the line 20 right here, or wherever you have your list comprehension, and evaluates this code. So in order to understand these list comprehensions, you can always just do this copying and pasting manually yourself, and then use the normal tools that we've seen, like with for loops, in order to understand what's going on. So that's the first thing I'm going to do here. I'm going to do what's called desugaring this line up here into this code down here. So this, again, a list comprehension, we sometimes call it syntactic sugar. Sugar just means that it's shorthand for some longer piece of code. And when I desugar, I go from the short code to the long code down here. So I'm going to comment this out, and I'm going to do the desugaring process manually. So over here in this explanation, I have accumulator equals this list thing. Down here in my actual code, the name of my accumulator is called greetings. So that's what I'm going to use up here. Instead of accumulator, greetings, start it equal to the empty list. So that's what this line right here is doing. You start it equal to the empty list. Whatever you had to the left of the equal sign up here, I'll start off as the empty list. And then now it says for variable in list. Well, my variable right here, my variable is equal to name, because it comes between the for and the in. So variable right here equal to name. So I'll say for name, and then in list, in the name of my list is names, plural. So it's down here in the accumulator itself, I had for name and names. So down here, the for loop looks like for name in names. And then I have this computation right here, adding it to the accumulator plus equals the computation, accumulator. And actually, it should be append the computation. Since this is a list, we add things to a list with append. Go ahead and make that a little bit more clear there. Accumulator.append. And the thing that we append is whatever comes to the left of the for loop. So here, what comes to the left of the for loop is hello plus name. So right here, hello plus name. There's a space after the hello. So these 3 lines right here are the desugared version of this line right here. And I'm going to save this real quick and we'll run this again and we'll see that we'll check to see if I get the same output. So previously my output was greeting equals hello Charlie. And then let's rerun this again, up arrow. Accumulator is not defined. This accumulator.append, it's whatever variable, whatever the name of the variable was to the left of our equal sign. So this should be greetings dot append, right, like that. Down here, up arrow, rerun that again, and it's telling me the greeting equals hello Charlie. So again, the takeaway so far is that these three lines 100% equivalent to this line up here. And anytime you see this this list comprehension, in order to understand what the list comprehension does, you can always just desugar it into an equivalent for loop, into an equivalent accumulator pattern, and then analyze that accumulator pattern instead of the list comprehension. Any questions at this point about how I got these three lines out of this line right here? Okay, a good thing, by the way, for the quiz in terms of note taking for today is that like this information that's inside of this notes.py is not in any way on your Python cheat sheet. The Python cheat sheet doesn't mention list comprehensions in any way. So somehow, and on the quiz, you're allowed to, again, use any written notes you want, but not electronic resources. So you're not allowed to have access to this notes.py file directly, but this would be a good thing to like write down somewhere on your like practice packet so that you can reference this formula on the quiz itself. And then also on these problems, like writing down what is the desugared version of each of these list comprehensions. For these quiz problems, sort of the simplest way to solve each of these problems is to do this desugaring step and then just like step through it like you've already done before for all the other problems. And you can answer all the problems on the quiz by doing something like that. In practice, in the real world, like when the reason people use list comprehensions is because we don't want to write this for loop. We don't want to think about the for loop. We want to just think like directly in terms of at some sort of higher level of abstraction. And so in practice, when people see these list comprehensions, they just somehow interpret automatically what they mean. And so if I'm thinking here, what does this like automatically mean? Then this greetings list right here, it's going to do this computation for each one of these things in here. And so looking at it, I can just sort of tell, again, with enough practice, that this is going to add the word hello in front of all of these names. And so my greetings list, just sort of looking at it, I can tell that it's going to be hello Alice, hello Bob, hello Charlie, hello Dave, hello Eve. And then, so down here, when I do greetings at position 2, I can just look at names, go position 0, position 1, position 2, and add the word hello in front of it to get the results. If you want to not do the desugaring and just work directly at the list comprehension level, that's sort of like the ideal place to be for list comprehensions. But you're also, again, for the quiz, allowed to do this desugaring and just work directly at the level of things you've already seen. Any questions so far? Yes, John.
Yeah, I mean, yeah, my code is exactly similar to that, but when I try to run it, it says like invalid syntax.
If you're getting something about invalid syntax, then probably there's not matched parentheses, or the colon's wrong, or the spacing's wrong over here. Yeah, I'll have to look at it directly to see exactly what the problem is. If you were writing your own list comprehension and you missed out like the in statement or the for statement, then you'll get invalid syntax on the list comprehension. A list comprehension must have both the in and the 4 inside it. If you only have the in like that without the 4, then you get this name error that doesn't know what this variable name is supposed to be. The 4 part introduces that name variable, and then the in is just something that's required for for loops. Any other questions about this problem 4? Yes.
If you wanted to say hello to multiple people, would you say greeting equals greetings 2 and then slice 4, for example?
Yeah, so this is a good question. The question is, like here we're only printing out the greeting towards one person. If we wanted to print out multiple greetings, we could do something like 2 to 4, something like this, and that now will extract, looking at the names list. Position 2 is Charlie, position 3 is Dave. We go up to, but not including Eve. So this will get Charlie and Dave printed out. So hello, Charlie, hello, Dave, and printing them inside of a list right like this. So this, on the quiz, some of the problems do interesting things like this after doing the list comprehension, but this is a totally like separate part. Like this doesn't, down here, it doesn't matter whether doesn't matter how we created this greetings list. It's just normal list slices at this point. And so whether you're operating on the comprehension or on an original list, it doesn't matter. The slices, this operation doesn't care how this list was created. Once you have a list, you can do any of your ordinary list operations on it that you might want to do. We can sort the list, we can slice it, we can index it, anything, we can for loop over it, any of those options. Good question. Okay, let's go ahead and comment this one out. And let's take a look at the next problem, problem 5 down here. And before I run this code, I want you all to try to think in your head, try without using the desugaring at first, try to think in your head, what is this list comprehension doing right here? And so what is the output of this going to be? So I'll give you like 30 seconds to think about that a little bit, and then we'll walk through it step by step what's going on. Okay, yeah, if you haven't, don't feel like you have an answer at this point, that's okay. But we'll just step by step go through what's going on this problem next. And again, the first thing I'll do here is I'll do the desugaring. So we'll talk about it from that perspective, then we'll talk about it from like just the directly list comprehension perspective. So the desugaring here, if I comment that out, we start off with xs equals the empty list for x in range 10. So again, whatever comes to the left of the equal sign is what gets the empty list up here. Then x in range 10, copying just this part of the comprehension, and then my computation is this stuff over here. So xs dot append x times x like that, and these 3 lines are exactly the same as this line right here. So each of the entries inside of this list comprehension, inside of this xs variable, is going to be equal to somehow x times x, where x is the index of that particular entry in the list up here. And so when I do xs at position 5, this is going to be whatever range at position 5 is squared. Range at position 5 is going to be 5. And if we run this, so 5 squared is equal to 25. So this excess at position 5, range at position 5 is equal to 5. And so we get 5 squared is 25. If we print out right here, print excess equals excess, so we can see what the exact like list was. Oops. And also let's print out the list itself. Print list range 10, list range 10. Then, so at position 5, it goes 0, 1, 2, 3, 4, 5. The position is just equal to the actual value on the range right here. And so we take, and down here, each one of these positions, or each one of these values is the corresponding position squared. So 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on up to 5 squared is 25. And so when I extract out that position right here, we get 25. Again, once you start getting more familiarity with these list comprehensions, once you see other people using them in interesting ways, or you start trying to use them, it'll become easy for you to just look at something like this and know exactly what's going on without having to do this desugaring. But if you want to do the desugaring and step through things step by step for the purposes of the quiz, that's 100% okay. Any questions on this problem? Okay. Usually up to this point, I find that students find things to be pretty straightforward. Maybe like not perfectly easy at this point, but straightforward about what's going on. And now things start getting the first like what's actually going on moment comes with this the second step right here. And so this is a slightly more complicated version of list comprehensions, where we have, so this part right here is all the same that we've had before, where it says computation for variable and list. But then the new thing is there's this if condition added over here. And so this is really the full accumulator pattern that we've been working with most of the time. Up at the top, there was no if statement, no filtering somehow in our patterns. Down here, this if statement is going to do some filtering for us. And in particular, that if statement is going to come down here, and our accumulator, again, it should be dot append of the computation instead of plus equals the computation. But this is the sort of exact accumulator pattern that we've been working with. So problem 6 is just like the previous problem, only we add this if statement right here. First thing I'm going to do is have us desugar this. So it starts off excess equals the empty list for x in range 10. And so again, here the 4x in range 10, this corresponds exactly to what I typed in here, 4x in range 10. I highlight that in VS Code, helpfully shows me that those two things are exactly the same right there. Then what's different now is that because I have this if statement inside the comprehension, I say if x %2 right here, and then my computation right here, xs dot append x times x, like that. So the difference here is that we've just added this one line, this if statement right here, which corresponds to this if statement over here. And now when we run through this, run that again, our result here is going to be 49. This one's a little bit harder to just directly like look at it without creating this whole list for us. But I'll add those print statements again, print list of range of 10 equals, comma, list of range of 10. I'm printing out again this list of range of 10 because that's the thing that I'm looping over. So this first print statement is what are the things that I'm looping over right here. And then the second print statement, print xs equals xs, like this. This is the actual contents of the results of the accumulation. And this one is defined after there, so I should move it below like that. Save that down here, rerun this. And so up here we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the contents of the range, the thing that we're actually looping over. But now my if statement over here, if x%2, you will see that this is only getting the odd numbers out of this list right here. X%2, again, this is sort of testing your knowledge about truthiness and falsiness in Python, that x%2, if that is equal to 0, then that we have an even number, and x%2 is, if it's 0, that is a false statement, so we don't go inside of this if statement right here. But if x%2 is non-zero, anytime an integer is non-zero, that is a truthy statement, so we do go inside this if statement right here, and we'll append this result for any of these x values that are not even. So we'll append this result for any of these x values that are odd. So coming up here, we don't look at the even values. 0 squared is not in this list down here, but 1 squared is. 1 squared gives me this 1. 2 squared, not in this list down here, but 3 squared is. And then we go to 5 squared, and then 7 squared, and then 9 squared. So it's getting the squares of all of the odd numbers, ignoring the even numbers. And then we're looking at the third, position 3 in this list of squares of odd numbers. Yeah, so again, you're welcome to do this desugaring on the quiz. As you're getting used to these list comprehensions, working in this desugared form is the easiest way to get started with these. But eventually, as you just see more and more examples of these, you start recognizing the patterns, and you can start working directly with these, the comprehension itself, just sort of knowing what that for loop is going to do. So same results down here, whether you use this form or this form down here. Any questions about that? Okay. So let's do another example with this new form. This is problem number 9 from the quiz. So this is what a sort of real world, sort of situation would look like a little bit. Up here, this is all, I don't know, kind of made up just to illustrate like the syntax of what's going on. But this is the sort of thing that in the real world people would be using list comprehensions for. So again, I'll give you a minute to try to work on this one yourself, and then we'll talk about what's happening. Okay, let's come back together again. So I have gone ahead and done the desugaring down here for this line 72. So again, always starting with the empty list at the top, then my for loop right here looks just like the contents that I have right here. The contents, the thing that I'm looping over is a little bit more complicated in this case. I don't just have a single variable right here, but I have an expression that evaluates to a list. So the sentence.split. So again, the split function is going to split this sentence on all of the words that it contains. So sentence.split is going to contain this, is, in, example, each one of these words being a different entry in this list right here. And then I'll loop over all of those words individually. I'll check to see if the word is small, if its length is less than 2, and only keep those words that are in fact have a size less than 2. So if I was, yeah, so we could step through this just line by line, thinking like exactly what each line is going to do. But if I were working on this like in the real world, what I would do is I would identify sort of like what each of these things are, what we're looping over, and then what this if statement is. And then just kind of manually myself walk over this list to count. I know I want the length of this, and just count how many words are there that have a length less than or equal to 2. So this is bigger, so don't count that. This, the word is, will satisfy this condition, so I'll count that. That's 1, that's 2, doesn't count, doesn't count, doesn't count. That's 3, doesn't count, doesn't count. That's 4. And then this is a tricky one right here. We get it with the period at the end. So the length of this one here is 3 and not 2. So this one doesn't count. And so when I run this, we get that there's 4 words that satisfy this condition. Those words are is, an, a, and in. We don't count it because it still has that period right there. And so it dot is not less than or equal to 2. I'm going to go ahead up here. We'll do a print statement. Sentence dot split equals, comma, sentence dot split like this. And so we can see like what is the actual list that I'm looping over. And then let's see like what is the actual like list itself, the results of this list comprehension like this. Down here, we run this. And so here is the actual words. We can see right here that this period is included in the it word itself. Again, split only splits on the spaces, doesn't split on the punctuation. And so then after doing this filtering, these are the 4 words that we identified. And so the final length is 4 right here. Again, like trying to get to this point where you can just read these list comprehensions directly is a good thing to do. You will see these, you'll see other people use these a lot in Python, and your own code can get much, much shorter and simpler if you start using these, but you're not required to use those. You can always go back to this accumulator pattern if you need to, and no problems in this class doing this instead of this up here. Any questions on this problem? Yes.
So do you have to have a computation, or do you just add like the word?
Yeah, it's a great question. The question is, do we have to have a computation over here? And like, what if I only want to do some sort of filtering, but I don't, like here I'm doing a computation of lowering the word, getting it all in lowercase. So the only place that affects is this first word up here. But if you don't want to have a computation, you always must have something to the left of this for loop, or to the left of this for keyword. But if you're not doing a computation, then this over here will just match this over here exactly. It's a great question. If we don't have any computation like this, something like that, run that. That gives us a syntax error right here. So if all you want to do is a filter operation, all you want to do is have this if statement to somehow reduce the size of your for loop, you still have to say just like for word in word, something like that. Good question. Any other questions about this problem? Okay. So this problem right here is again like this is what I would call this very idiomatic Python. This is something that a practicing programmer, somebody working at Google, Facebook, any of these big companies, whether you're in like the hardcore software engineering role or the more high-level data science role, people will use this kind of list comprehension all the time. And it's not really controversial to have a list comprehension about this level of complication. Pretty much everybody would agree that this is better than this down here. Question?
In this case, would the word dot lower actually do anything helpful? I know lower this, but anything else wouldn't be lower. So it wouldn't really do much in terms of the
In this,
output.
exactly, in this particular case, because this if statement happens to filter out the only thing that has a capital letter, then you get the same exact results with and without the lower sign right here, or with and without the lower function. Good question. Yeah, so this totally uncontroversial list comprehension and something that a practicing Pythonista is able to just look at and understand what's going on in their head. This section 3 down here, we're starting to get into the more controversial level of list comprehensions. And some Python programmers would see something like this and think, oh yeah, that's totally easy to understand, and do it in their head. Probably most Python programmers though would think that this is starting to get too complicated for a list comprehension, and prefer writing this in a for loop. Or even if they have something like this, when they try to like think in their head what it's doing, they would manually do the desugaring to understand what it's doing. So what's more complicated about this list comprehension right here is actually that there's two list comprehensions. We know there's two list comprehensions because there's two square brackets right here, and each of these lists contains the for keyword. So here's the inner list comprehension with this for loop right here, and then this is the outer part of the list comprehension for this outer for loop. So again, this is problem 15, so on your notes packet. And we'll go through and manually do this desugaring to see how to evaluate this. When you're doing this desugaring, what you'll want to do is desugar things just like one for loop at a time, one list comprehension at a time. And you always start from the outside and work to the inside. So you always start desugaring this outer one, and then you can desugar the inner one if you want to. So I'll comment this out for now. And we'll start with XSS equals the empty list. And then the for loop that I choose is the outer for loop over here, not the inner for loop. So for X in 2, 3, 4 like this. And then if X% 2 equals 1, then here's my computation right here. This inner list comprehension is what my computation is. So XSS dot append the inner list comprehension. And I'll just go ahead and copy and paste that right there. So these 4 lines right here are the desugaring of just the outer list comprehension, not thinking yet about the inner list comprehension. We'll talk about the inner list comprehension here in a second, but are there any questions first about why what I have written here, why these 4 lines are equivalent to this line up here? Yes.
The outer, like, so like, is it, how do you like, you say that like you should do like the one in the middle, like 4x and 2, 3, 4, like that's where you should start and then work outside.
Yeah, so when I say going from outer to inner, what I mean is that you look at the square bracket that's on the outside. So this square bracket right here, they're on the outside. These square brackets right here on the inside. And so I need to find the for statement right here that corresponds to the outer square bracket. There's two for statements inside of this square bracket, but this for is inside of this one right here. So it's this for that I want to look at because it's outside of the inner square bracket.
Okay.
And similarly, this if statement right here is outside of the inner square bracket. It's only inside the outer square bracket. But yeah, it's very, very easy to get tripped up on this and accidentally look at the wrong sort of for loop on this problem. So that's one of the reasons why most Python programmers would think this is too complicated, because it's easy to just look at the wrong one on accident. Good question. Any other questions on how I got to these 4 lines out of this one line right here? Okay, so at this point, again, like the professional Python programmer is going to be able to look at this list comprehension and just know exactly what it can do and not need to desugar this line right here. But we're going to go ahead and desugar this line as well. And so in order to do that, I'm going to need to introduce a new variable that corresponds to this list right here. And we'll say that that variable is just XS. It doesn't matter what that variable's name is, but we'll choose XS. And then for, again, copying the contents of this for loop exactly right here for I in range X. And then we append the computation right here, which happens to be a very simple non-computation. XS dot append I, like that. And so, and then we still need this XSS dot append XS. So this one line right here corresponds to these 4 lines down here. And then all, what is this, 7 lines, all of these 7 lines together are exactly the same as this one line up here. And now that we have this whole desugaring process, we could go through our like step-by-step procedure that we're familiar with and evaluate exactly what's going on right here. I'll go ahead and save this down here, run it. And so we get the value X equals 1. And yeah, we have to, at this point, in order to really understand why this is going X equals 1, I would probably copy and paste this whole desugared thing into Python Tutor and step through the whole thing line by line.
In terms of, I know it's checking if it's true or false with the double equals. And so that means if it's an odd number, then you would do the next line, correct?
Exactly.
So only one odd number. So how come why does it work if it asks for 2 index values of XSS?
Yeah, so the question is how we have 2 index values down here. What exactly is going on? And so let's go ahead and do a print of XSS equals XSS right here and see what the contents like this is. Down here, up arrow, rerun. And we see that, so this is the result of the XSS computation, that we get a list of lists. And so this very first indexing at position -1 is looking at this very outermost list. And so XSS at position -1 gives me this list right here of 0, 1, and 2. And then we're looking at position -2 in that inner list. So this is position -1, this is position -2. In general, when you see these nested list comprehensions like this, the result is going to be a list of lists. So here again is the computation. These are the values in the outer list. The values of the outer list are going to be another list. And I know that because there's this other list right here. this thing that I'm appending right here, if we go ahead and think about it like this thing that I'm appending to the XSS list, this thing right here is another list. And so all the values of XSS are going to be another list. And so that's why we have these two indexings right here, because it's a list of lists. This gives me an individual list, and then this gives me an individual number.
I see, so it was just XSS 0, and then we print out that 0, 1, 2. It's only different full list, that makes sense.
Yep. So if we change this to X equals XSS at 0 like this, and try that again, then we get X equals 0, 1, 2. And this is exactly the sort of thought process that you want to be going through when you're working on these sorts of problems. That again, we are computer scientists. Scientists go through the scientific method of creating a hypothesis and then running an experiment to test your hypothesis. And so the hypothesis that was just suggested was that this XSS at position 0 would give us a list back with the content 0, 1, and 2. And we tested that hypothesis by actually printing out that value. So that's exactly the right way that you want to be approaching all these practice problems in the quiz packet, is coming up with a hypothesis about what is the code doing at a certain spot, and then coming up with an experiment to evaluate that hypothesis. That experiment could look like adding print statements like we've been doing to see what are the contents of the intermediate steps, or just changing the result of what we're printing out at the end to see what would it look like if we were indexing at a different way. But always coming up with experiments to evaluate hypotheses is the right approach to these problems. Great question. Any other questions about this problem here? Okay. So again, this type of, this is a very complicated list comprehension. This is more complicated than most Pythonistas would think is like good in the real world. When list comprehensions were first being added into Python, they're a relatively new feature. They're only about 10 years old. Python, again, is about 30 years old. When these comprehensions were first being added into Python, Guido was very skeptical of them because of, like, you can get really ugly sort of things like this. And nobody is able to just look at something like this and evaluate it. Everybody would have to desugar it. And so in practice, you won't find many list comprehensions like this, and you should be skeptical of yourself if you're writing something this complicated. That said, you will have at least one super complicated one like this on your quiz, so you need to know how to work through it and evaluate it. Okay, number 4, part 4. So there's another like extremely real world application here. This comes from the very last problem on the quiz packet, problem 19. There's this big tweets variable that has a whole bunch of tweets sent by Donald Trump. And we could analyze these tweets by doing a for loop over these tweets. That's what we've done in the past. You've had previous labs that have been looking at something like this. But most of the time when we're doing something like this, it is beneficial to use the list comprehensions, something like this, in order to do your analysis. And I forgot to comment out these things up here. So let's do that real quick. Save that, come down here and uncomment this. And again, this is like an extremely like real world thing where you have a very complicated list that you're trying to analyze, and so you have a list comprehension to do that. I'll give you another minute to try to think through, work in your head, try to work at like the high level, thinking about just what is this list comprehension doing, evaluating it, seeing how many of these popular tweets there are. And then we'll come back in a minute to to talk about it. Okay, let's take a look at it together here. So this popular tweets, I've just put the sugar for it, the desugared version down here inside of a comment, always starting with an empty list, looping over whatever we have right here. In this case, there's no computation going on right here. There's no, this thing before the for loop and the thing after the for keyword match each other. So there's no computation going on inside of here. The only thing that's happening is a filter over here, this if statement down here. And then down here, we're trying to just count or return the number of things that are left behind by this filter. This filter right here is for each one of these tweets, each one of these entries inside this list is a dictionary. And so we're looking in that dictionary at the key retweet count, the total number of times that tweet has been retweeted. And we're deciding that something is popular if it's been retweeted at least 100 times. And so looking through here, we count how many times is retweet count greater than 100. Well, these first three right here, they all have very small retweet counts, not popular for whatever reason, so we don't count those. But then all the other ones have larger values. So there's 1, there's 2, there's 3, there's 4, there's 5. So I count 5 of these tweets that have at least 100 retweets. And so if we save this and come down here, my hypothesis is that the length of this variable is going to be 5. And if we run that, we can check whether that hypothesis was true or not. And there it is. Question?
In terms of the differences between, so for problem 9, it was very similar, but it printed out the actual number of like words in it, whereas this time it prints out, from one prints out the number of words total, or this one prints out the number of words, not in the tweet itself, but the number of tweets and the number of words itself.
Yeah, so okay, so the question here is thinking about the difference between problem 9 and problem 19, that in problem 9 up here, we were looking inside the contents of a string and trying to print out, or like thinking about what is the number of words in this string. And here, when inside of this for loop, the thing that we're looping over right here, sentence.split, that is equal to like each of these words individually. I'll go ahead and save this up here, come down here, run it. And you can see right here, sentence.split is the list with all of the individual words in it. So when I'm doing a filter, I'm filtering over those individual words because that's what is to the right of the in over here. That's the thing that I'm looping over. And then the question is, how is problem 19 different than that? And the key idea is, what is the thing that you're looping over right here? Here I have for tweet in tweets. Tweets is this list right here. It's not a list of words, it's a list of dictionaries, a list of tweets. And so the thing that I'm filtering here is not individual words, but the thing that I'm filtering here is is over dictionaries. And so that's why it's counting dictionaries. I could modify problem 19 so that it would be similar to problem 9.
Maybe it's like a text variable.
Yeah, so let's create a variable text that's equal to tweets at position. Let's just pick one like this at location text. So tweets at position 1 at location text is going to be equal to, let's do just -1 so it's easy to see on the screen. That'll be equal to this string right here. Let's go ahead and verify that that's the case and print text equals comma text and run that, print that out. And we can see that this text variable equals join at American 32, blah, 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 equals this text right here. Again, I know that this text variable equals this string right here because I take this list, find the last element in this list. This dictionary is the last element of the tweets list. And then once I have this dictionary, this whole thing right here is the dictionary. I look at the particular key where it has text. This is the key text, extract that value right here. And that's going to be equal to the this text variable. Now, if I were to say something like words equals and use our list comprehension here of word for word in text dot split, and let's print words equals comma words like this, then this variable right here is going to be equal to all of the individual words that we have up here. Save that, come down here, rerun it, and here's all of those individual words. Again, the punctuation marks don't get split out. They stay associated with each word. And so those are all of the words. And we could add a filter. Maybe instead of doing words, let's do mentions. So Twitter mentions start with the @ sign. So we want to count if the very first letter in the word is an @ sign. So if word at position 0 equals the @ sign, then it's going to be a mention. And down here, say mentions equals mentions like that. Come down here, rerun it, and we can see that there's these two people were mentioned inside of that particular tweet. So yeah, like in some sense, this is a pretty complicated thing that we've just done here. We've looked at this particular tweet, extracting out all the other Twitter users that were mentioned by Trump in this tweet, and we've done that in only a single line of code. And so these list comprehensions can be pretty powerful that way. This right here, again, is only working on a single tweet. If I wanted to extend this to work on all tweets, then, well, maybe before I do that, I'll stop and say, are there any other questions about why this is extracting the mentions from this very last tweet right here? Okay, if I were to, so let's change this again. I'll comment this out so we don't have to delete it. If I were to change this to say mentions equals list of, and we'll start by just copying and pasting that exactly. But here, what I had up here, this text, this was the text of an individual tweet. If I change this so that this text is the text of like all of the tweets, by doing something like for tweet in tweets like this, and now this text variable. So this is my outer for loop. This outer for loop is going to loop over all of the tweets up above. And then we need to somehow extract this text. This text was equal to this right here is the individual tweet at position text. So tweet at position text like that. Now this is going to give me all the mentions and all of the tweets. Print mentions equals mentions. It's going to be a list of lists. I know it's a list of lists because there's these 2 square brackets right here. save that, come down here, run it. And so here is all of the mentions that Donald Trump has used in any of those tweets. Some of the tweets had no mentions inside of them, and then some of those tweets had multiples. This one had only a single mention, and so on. So again, this is a very complicated list comprehension, and this is starting to get into, like, in practice, most people would find this to be really ugly to work with and understand. And yeah, but it's a fairly extensive computation that we've done here in just a single line of Python. So in some sense, Python's very powerful that way. The syntactic sugar gives us a lot of power that we can do in just a single line. Yes.
And if we didn't want those empty lists to be in our nested list area, we wanted to just have nothing there, what would you?
So the question is, how could we filter out these empty lists so we only had the lists that contained that actually contained contents? Anytime we're doing a filter of a list comprehension, then we add an if statement to the filtering. Here, the thing that I want to filter is I want to filter out of the outside list, remove certain elements that are inside of it. And so right here, I can say have an if statement. And this is, there's no, like, what I want to do is if this entire list right here, if this length is very small, then remove it. So if this length is 0, there's no easy way to actually reference this list. So you have to actually copy and paste this whole thing. If that whole thing, the length of that whole thing is equal to 0. We only want to keep it if the length is greater than 0. So run down there, run it, and now it's removed all of those empty lists. Now this is a monstrosity of a list comprehension, and this is not something that I guarantee there's no Python programmer in the world who would find this thing something that you would actually want to use. There's competitions in every programming language of, like, how can you get a one-line, like the most interesting one-line program? And so this is the sort of thing you could do to get an interesting one-line program. There's other competitions of, like, how can you make code that they call it like an obfuscated competition, where you make code that does one thing, but people think it's supposed to do something else. And so this is the sort of tricks that people use to make their code, like, hard to read on purpose. In the real world, you don't want to do that, but people have fun doing that just to do it. Yes.
This is sort of on the lines of the lab of the project, where we're already getting some of the values from the keys.
Mm-hmm.
And so this is already, I don't know, like at least 20% of some of the projects, so you could incorporate.
Exactly. So yeah, the reason why we're talking about this right now is because it's a great thing to incorporate into your project of, like, okay, you've loaded this data somehow, and then once you've loaded this data, you do a single list comprehension somehow to get the data in the format that you want it to be to plot it, and then you call those plotting functions. And that's a great way to practice these list comprehensions. And that's one of the main sources, especially as a data scientist, that you'll see these list comprehensions. You'll see them coming right before one of these plot functions in order to decide what it actually is that you're plotting. Great questions. Any other questions about anything list comprehension related? Okay, it turns out that besides list comprehensions, there's a thing called dictionary comprehensions, which work very similar to this, only you have curly braces out here instead of square brackets. You're not responsible for those at all for the quiz, but if you're interested in those, then, whoops, I have bad markdown formatting here, it looks like. This reference over here goes into dictionary comprehensions, and this video tutorial right here goes over both list and dictionary comprehensions. Again, summary for today that we've seen before that like while loops are somehow the most powerful like looping construct there is. They're more powerful than for loops. You can do things in while loops that you can't do with for loops, but that's actually a bad thing. You don't want to use powerful things when you can use less powerful things, because while loops, for example, can go into infinite loops, and you know that for loops can't. So for loops are guaranteed to have fewer bugs than while loops. Similarly, list comprehensions are strictly less powerful than for loops. We've seen every list comprehension you can implement with a for loop, but not every for loop can you implement with a list comprehension. If it doesn't follow that accumulator pattern somehow, you can't use a list comprehension. Maybe it has 2 if statements inside of it, or if it has 2 if statements, you can't use a list comprehension. And so these are specifically like very, very simple for loops, and again, you're not required to use them, but they can make your code like this really simple, or like this super complicated and hard to understand. That's it for today. If people have, we'll end a little bit early. If people have questions about things, happy to talk about it after class one-on-one. Otherwise, we'll have the normal lab session on Friday. Yes.
So the syntax are time, but it's on the very first line.
Scroll up to the first one. You go ahead and run it.
Oh, let's just use the first one. Yeah, that's good.
So right now we're in interactive Python mode,
Oh, okay.
and the triangle button doesn't work inside of it.
Okay. And just another thing for the notes dot yeah, JSON. Yeah, so I did integrate all of the condensed years, and then it still says num tweets equals 0. So
So here you have a capital Trump in lowercase text.
oh, okay.
So does it make sense that capital Trump will never appear in lowercase
Okay.
text?
Okay. So
Yeah, now try that. So you're in interactive Python mode again? Yeah, so you have to get out.
Did you finish? No, I scheduled it for 3 o'clock.
okay.
Does that make sense?
Yeah. Thank. And so will it detect? Will this detect all Trump, like regardless of the upper and lowercase composition? Got it. Thank you.
So for the lab, I managed to get the output like this, but when I fixed it into high, it ends up.
Don't worry about that, it's fine.
Okay, and also can I move in your office to talk about the project for this weekend? Thank you. Yeah, I'm like lost on this part of it. I'm just gonna watch. It's like a thing of like it's kind of bad. So I've tried this one. Just me.
Sorry, what are you working on right now?
So this one's just but I think.
So this
Oh yeah,
lab.
so I'm looking at lab more too. Do you think it's so
Okay.
the issue is that
Oh god, that hard. No, it's really like
this
but this is
Yeah.
That's why I haven't started. I don't want to start it, do it the wrong way, and then
so this
like I want them to show me the exact way to start, so I don't mess up. Because this is the first part of the JSON file, so I want to.
the issue with the way it's making like -1, go back there.
So you're not
Good, good.
comparing with the
I
previous.
do think an hour today, an hour.
Oh, wait,
yeah.
Comparing with the previous.
Yeah.
Like
Yeah. So this
Okay,
one,
good.
because the first value
Which starts this week, bro.
So you're always at the first.
exactly. So that's what we're trying to do right now.
So one thing that's confusing is that whenever I see an X variable, I'm thinking X, like I think I have 48 total. Like the X is the entries inside the list. When I see the I, I'm thinking that's like the 0, 1, 2. And so whenever I have a for loop that's for, I do for I in a range and for X in a list.
Honestly, that's probably gonna make my life a little bit easier to do that. Yeah, so for I in range.
Anytime you have an I for
Yeah.
index, X for the value.
Yeah.
And so if you want to, so here where you have excess of X minus one,
So let's get I minus one.
so yeah, change those to I's.
Because she came out to me at the breakfast today, and I'm like, yeah, like,
Okay, and then I
it
think
just becomes really
if
annoying.
you
Like,
delete
for me and her too.
159,
Like, I don't
just
want
those two
I was
things
thinking,
above.
oh, I think she messed
So wait, I just.
She's not
So you're not, I don't think it's removing duplicates everywhere. It's only removing it if it matches the previous one.
Dang it, I took all the.
And you don't actually, so that will have a problem if the list is like the 0, then 1, 1, 1. Here, we need to not just check that it's equal to the previous like this, we need to, that one needs to not be added. So if we check if excess I equals whatever your accumulator is. At the last position.
Oh, oh,
Now that'll work.
that
no matter how
might
much you
actually
do
be a lot smarter way to go about that. I'm not gonna lie to you.
It's so smart.
Holy moly.
About that.
Yeah, lots of very subtle tricks like that, that once you see it,